So I've just been listening to Stephen Wolfram talking to Dr. Brian Keating on his YouTube channel about dark matter and Stephen Wolfram's idea for dark matter. Now, his idea for dark matter is very close to my own idea, but he says that it's space-time trapping heat, which is something I could not agree with more. I think that's absolutely on the money. I think that's totally the right answer, or very close to being the right answer. I think the detail that he's missed out is that it's electron densities surrounding, say, the supermassive black hole at the center of our galaxy, um, trapping that heat. So this is, yeah, roughly speaking, what I predicted. This is that electron densities, it creates more resistance. The closer you get to the centers of galaxies and the extremities of galaxies, so you have these rotation curves that Vera Rubin et al. Sort of discovered back in the 1950s and so on, or the 1960s or whenever it was, and yeah, the reason why is because stars moving closer to the centers of galaxies, they've got to go through a greater density of electrons, and of course, electrons repel one another by exchanging photons with one another. So ultimately, the reason why that repulsion occurs comes down to radiation pressure, and heat, of course, is photons. It is radiation. It's radiation, right, that heats things up, causes things to oscillate. We can translate this idea of heat into the idea of radiation. I'll give a link to the video with Stephen Wolfram talking about this down below. But yeah, it's the finessing of that idea of Wolfram's would be to include electron densities in this idea for dark matter. But it's electrons, because you know that electrons readily interact with photons. If you have a huge cloud of electrons surrounding, say, a star or a planet, it traps their huge amount of photons and causes stars to have a reflective capacity, causes things like gravitational lensing as well if you apply it to galaxies or very dense galaxies, um, around which gravitational lensing occurs. But yes, I really like that answer a lot. Heat. Absolutely, it is. Um, that is absolutely on the money, I think. And I think it's going to come out of a private endeavor, probably the Wolfram Physics Project, who ends up coming up with the answer for dark matter. And yeah, I mean, hopefully I get some credit down the line for having also thought of a model in which it's as near as makes no difference the same fucking thing. It'd be nice to get some credit for it, but there we go. Yeah, dark matter as heat. I like that. That's very, very good. It just needs finessing a little bit to say that what's causing the heat to be trapped by space-time, what's causing this reflection of photons trying to escape from stars and black holes is the fact that stars and black holes are surrounded by tunneling electrons. It just needed to go a little bit further, I think, and make that final jump. And then you have a theory of quantum gravity, along with a theory of dark matter, um, along with actually a theory of dark energy, because since dark energy can be explained thereby via the build-ups by radiation pressure again, radiation building up between galaxy clusters and driving the expansion of the universe, driving the universe's accelerating expansion. So yeah, it's nice to have had the same idea, I think, since, as I said in my model, it does involve radiation pressure, since it involves the mutual repulsion of electron densities, and electrons repel one another via exchanging photons. So it's the same idea, more or less. Very exciting to have this now. Hopefully, we're at the verge of turning over a new leaf in physics and coming to a grand unification epoch in the sciences, or in the particular science that is physics, and we can kind of coordinate our efforts towards finding out what not the ultimate theory is necessarily, but what a step towards the ultimate theory would be, or gaining an enhanced understanding, I think, is probably a more reasonable expectation of gravity and of the forces that hold the universe together. And yes, dark matter as trapped heat, giving rise to radiation pressure. So you have all this radiation surrounding the centers of galaxies, slowing down the stars and planets and whatever else moving around the center, and allowing stars traveling at the extremities to travel more quickly. That makes a hell of a lot of sense to me. It fits perfectly with my model. Thank you very much, Stephen Wolfram, for saying that.